uploading, and then we'll wait for them to show up. We need to wait.
Okay.
Tu as viré le...
Yeah, go ahead. So we'll be starting in a minute.
If the network is kind with us. Okay, so let's see. I will share. Hopefully. There are many mails.
Salut.
Laisse-moi faire tout ça. Je ne sais plus lesquels c'est lesquels. On fait comme d'habitude, on donne 5 minutes aux gens d'arriver en retard.
Non, on démarre. C'est bon.
Je vais tous les chercher. Benjamin, architecte meeting sheet, je n'ai pas besoin. Convergence, je n'ai besoin. C'est bon. OK. Tu fais l'intro?
Oui, oui. OK, je fais après. Tu fais. So, hello everyone. We're ready to start. So this is the fans are here. So this is the meeting of the LP1 working group, and we're very happy to be here for the first time since a couple of years. Since a couple of years now, and we're very happy to see everyone that is here in the room, and also the people that are remote. So thank you for being here. And with this, as usual, the Note-12 applies. So you should read, of course, all the BCPs that are listed here. You should be aware of them, especially things related to APR, to anti-harassment, code of conduct, and all these. So please adhere to these rules that are written here. So we have a couple of meeting tips for this meeting. So the first is we ask you to wear a mask unless you're eating or drinking actively or speaking on the microphone. So we have a big room here, so you know if I think we're pretty good in that aspect. Yes, so we have the laser pointer here that will be, the presenters can be using. And also, so we have the Meet Echo, so you can, join the queue, and, whenever you don't want to say something, just join the queue, raise your hand, and we'll give you the word for that. Or you can also type your comments, and we'll be saying that on the mic. And make sure, of course, your audio and video are off. Sorry?
Tu peux l'utiliser aussi.
Ah oui, je peux l'utiliser aussi. Ah ben merci. Thank you. Let's see if it works. I'm not sure. No. Okay, so that doesn't work, I think. Yes. So the agenda is. We need to turn it on. Yes. It will work later. So the agenda is on the data tracker, so you can see it there. The Meet Echo information is here, of course it is showed, and if you need some technical assistance, we have the link that is also pointed out there. So there, let me. What's happening now? So about the scribes, so we already have Ivan and Sergio that are going to be taking the minutes. So thank you both. But of course, if please help them in the minute taking. You know that's a difficult task. So and it's really important that it's done well. So please help our scribes for that. So give us just a second because there is something with the slides. Ah, the network is having some issues.
It keeps falling and we lose connection.
Oh, okay.
Wait for sure.
Okay.
Yes, we have it.
Yes. So this is the agenda for today. So we start, of course, with the opening. Then we are going to have a discussion about the rechartering that we have been talking about we have been discussing a little bit in the past. Then we have a new work to be presented, so SHIC convergence profile from Sergio, and a discussion about IDs that is going to be led by Laurent. So we have about an hour and a half for today's meeting. So do you have any other work that you would like to discuss on today's meeting?
Dominique will have 2 minutes for the.
Yes, so there is a new item we will include. So 2 minutes from Dominic about the hackathon, because there were some really interesting work that has been done. So we'll be adding this one. You can start at the beginning, I think. It's good to say a couple of words.
Did you
Yes.
send the slide? I've not seen it. If you like, yes.
Yes. So,
But you'll have just a few minutes.
yeah, yes. So the question was if Dominic, so Dominic asked if he needs to upload slides for this, and yes, if you can upload a couple of slides, yes, but it's not like, I mean, we can just orally present it as well. Yes, just orally. So any other items that you would like to discuss today?
May I suggest to put the rechartering discussion at the end?
No, because the key members are going before the end of the meeting. And so, yes, it would make sense. We wanted to do that, but we will be losing a few members.
Hmm.
So that's why, sorry, Eric.
Yeah, that was we also wanted to do.
Discussed
Yes, but
same
that
logics and
that was a very good proposal. But you're perfectly right. But we need to keep that one. Okay, so can you switch to the next slide, please? Okay. So in the working group status, things are advancing pretty well. So I think that in all working group items we have serious. I mean, we're always almost finalized the work on the open working group items, and we'll be talking more about the status of NB-IoT and Sigfox. And there are some working group items that we'll need to discuss. You know how things are going to evolve from here on. So here on the shake over Sigfox and the compound DAC. So we're almost there. We are only waiting for the final touches. I think there is the shepherd. So Anna is the shepherd of the shake over Sigfox, and is to push the button. I think that's the only thing that is remaining. And on the compound DAC, I'm just waiting for the latest revision to be published. There were some nits. I think they were fixed in the GitHub version, but I just wait for them to be published as in the data tracker, and it's good for me. So I'll push the button, and it will be sent off to the ISG. So yes, Sergio.
Yes, I will check the compounded draft. I think is ready, the latest version with all the corrections. So maybe we can check that, or else I will publish a new version after the meeting.
I don't think it was on the data tracker. There were some nits, it was really minor stuff, but I don't think it was in the data tracker. They were not fixed in the data tracker yet.
I think they are, but I will check it then.
Yes, okay. Please double check, and it's good for me. I'll push the button later, just right after. Yes. And Anna, I'm not sure if you're hearing me about yes. So Anna is in the queue. If you can say if she covers Sigfox is good for you, and if you're ready to push the button.
Hello.
Go.
Yes. For me, we are waiting for the end of the last call, so I can press the button when you tell me.
Well, let's press the button then.
Okay, so
Okay.
push push the button.
Okay.
Okay,
Okay. Great.
perfect.
Or we do it, maybe she cannot, maybe it's us. Like,
She needs as a shepherd needs to push the button.
don't know if she can.
Ah, okay.
We'll check.
We'll need
And
to
now
check.
maybe you can't. I have to check if the button is active for you. If you tell us you're ready, we can just press it. We can just press it.
Okay.
Okay, so that's good. That's excellent. Now on the document advancement, so we have the Yang data model. So the work it's done, right? Right now it's in the editor's queue, and I think that was a huge amount of work. And with Pascal, we would like to thank everyone that has been working very actively, the whole working group, and Laurent and Anna for really taking the pain and taking the effort to making sure that we have this good Yang data model. That was, we were waiting for that document, and so thank you both. It's really an amazing work. So we're just waiting for the number. I don't think we have the number yet of the RFC, but it's coming. So excellent work there. NB-IoT mostly, so it's also very well advanced, the shift over NB-IoT. So there are the exchanges with of course, the liaison with the 2GPP that is currently again being discussed. But the work is done. There has been a lot of reviews from the ISG that went really well. And I think there is only one discuss that's going to be cleared. So it's good to go. And again, amazing work there from the authors. Yes, Pascal wants to say something.
Yeah, sorry for the interrupt. I just want to say that I've never seen a document going so smoothly through the ASGQ. So don't ask me, but I think it means it's an excellent document. And Eric, if you want to chime in, but no, I don't think there is even a discuss. I mean, I think it's just going to fly. And now for the whole.
Yes, Edgar and Anna.
There were a lot of exchanges, a lot of work by Anna and the ASG. Very, very, very.
Yeah, regarding the NB-IoT, Pascal and myself and Dominic was there as well at the 3GPP liaison meeting on Tuesday lunch. They were really welcoming for the work. So if enterprises wants to continue the work and it becomes part of 3GPP, they are wide open to submit a SID and work ID. But of course, it's not the IETF to do it. So if you really want to get the work done there into the 3GPP standards, the door is open. Now, regarding the document itself, it will be reviewed by 3GPP next week. We may expect maybe a review the week after. So I would wait until end of November to reassess, last discuss about how we do the informative part versus the normative part. So don't touch now, put in sleep mode for 3 weeks.
Yes, thank you very much. Thanks, Eric, for that clarification. So again, a really amazing work. I think it's, I mean, we're very happy with how things are moving. So we discussed the Compound Act and the Shake over Sigfox. So they're going to be submitted in the next week or two. So there is the document of the OAM, and the question is, of course, if there is still interest in continuing that work of the current authors, if there are going to be new people that can join the work, right? So that's an open question. Dominique maybe can tell us a word about this.
Dominic, you're supposed to press the button to ask for the queue, but that's okay.
Yes, I
Anyway, there was only Laurent, so it doesn't really matter.
As far as I'm concerned, I'm interested in continuing this work, and I may have even more time on my hands in a few months. So.
Okay, that's perfect. Dominique, we're very happy to hear that. Yes, and I think it's an important document, and we're all.
I think Laurent and Yvonne, speaking for them, are still interested in that topic since they are implementing it. So I think we're good.
Thank you, Laurent.
Thank you, Laurent, and thank you, Ivan, as well. Okay, so that's good. So everything is still alive, and we'll have advancement. Okay, so Pascal, you can say a couple of words on architecture.
So the architecture has progressed with regard to the description of how SHIC works on any type of connectivity, meaning that we recognize that there is a session between a device and an application core. And that session was implicit in the case of classical LP1 networks. So all the parameters were well known. There was no really negotiation, but we figured that on more diverse type of networks, then there will be a need for something more. And so the architecture is preparing for that, and the rechartering will prepare for that as well. As we take that path, we will have to work on how we identify the session, what kind of data is maintained together with the session. So that's also part of the discussions that we hope we will have today, and that we have started in an informal meeting between the usual two authors. But basically, that will be the core subject of the end of this meeting today.
Bob Moskowitz, I made a comment on this draft back when I think this version came out, that the security section is incomplete. It only has security above transport. It does not have security below transport, i.e. ESP, IPsec. It's not in there at all. And the implications when security is below transport and what you do for within that security envelope compression, higher levels, particularly if you're running a tunnel and the rest of that. That is not in the architecture and should be added to the architecture.
Sure. At the same time that we discover the fact that we are not working on a close link like LoRa or Sigfox, and we go over FOO, then we need to look at all this. Before that, it was the layer 2 security. It was just a direct layer 2 connectivity. So again, it was all implicit. And now we have to make it explicit, and we have to discuss it. So that's part of the SHIC over FOO rechartering discussion, and the architecture will cover that. It needs,
Okay.
and your help will be welcome.
That's right. I just signed myself up for something else.
Yeah. Well,
Congratulations.
we have 5 fingers. You only subscribe to 4 right now.
Yes. Okay, so thank you, Pascal. Thank you, Bob. And we will have a new work presented today also on convergence. So this is where we will be entering the discussion about the rechartering. So Pascal, you can lead the discussion. We'll try to have it like we have 15 minutes, I think, to outline this one.
So we already had started that rechartering discussion last IETF and a number of interim. And we are kind of accumulating the list of things we would wish to work on. And that list that you see on this slide is becoming serious. And at the same time, we kind of rapidly consume the list of documents that we are working on because they are rapidly passing to the ISG. We've seen NB-IoT, we've seen the data model, which are pretty much through. And coming up are the Sigfox document and the Compound Act, which are pretty much done for this working group as well. So I think, as chair, that it's really time that we work on this rechartering and we start proposing text to the AD, if you don't mind, Eric. And the subjects that are listed here are basically, taking the feel of the group, whether we want to work on those items. So these are the items that we have kind of found we could be working on. First one is, so please feel free to come to the mic and say, oh, we can't work on this, or yes, I would like to work on that, or just raise hands. Maybe we can do some show of raise hands if people are interested in subjects. If you can rapidly go through raise hands, I don't know. So first thing is SHIC over FOO. As you know, we are chartered for 4 technologies. One of them is actually being processed in a different group because Carles' work is done at 6LO on 15.4. And the other technologies we have done at home. Now, we discovered there are a lot of new foods. There is PPP. We tried to push the work on PPP at the interior, but the skills and interest were not there. So probably would like to take it back here. There is interest in generic IP, the tunnels. There is interest on a new aviation radio technology called Mavlink, and we have effectively hands with a lot of fingers on them, ready to start working on this. So that's the first charter item. Any comment on Chic over Foo? Is it something that seems to raise interest in this group?
Yes, so Juan Carlos on the mic.
Yes, hi, Juan Carlos Zúñiga. I do have interest and I support the topics. I see that we are expanding the usage of SHIC beyond LP1. And that's clear from the list that we see here and the fact that we are having to discuss sometimes with Interias and some topics are being discussed in 6 law. So as much as I support the work of these topics, I wonder if this rechartering should also consider changing the name of the group or the scope so that it's clear that it's not focusing only on LP1 or if what is to do, because SHIC is definitely a generic technology that can be applied over multiple areas. It was created with the purpose of LP1. But
if we rename it, like the group to be called Chic, really, even if it
that
spells like the French
or coordinate closely with 6
that
law,
would be
or
neat.
I don't know.
Yeah, I mean, what you propose, Juan Carlos, is indeed logical and sensible. The only thing, if I remember correctly, another working group wanted to change its name as well. That was no way, right? It's simply a tooling system in data tracker that makes things complex. So I can ask again, but indeed it's no more LP1. So we should create the SHIC group, which is kind of cool as well. But
That would be neat.
Yes.
So second item is fake fragment. So this one does not really take rechartering. It's about providing a new method within SHIC for handling fragment loss. And basically, instead of doing an ACK or NAC type of ARQ technology, we would use forward error correction instead, meaning that we send more bits than we need to in case some of them are lost. So that's that item we can take within the current charter.
Not instead of, but in addition to.
Oh yeah,
You may still have ARQ with FEC.
yes, it's
That's the nuance.
okay, because you mean they could be both active at the same time. That's what you have in mind. Yeah, okay. So HARQ. That's what HARQ means, hybrid ARQ. That's when FEC and ARQ works together. So we need to rephrase this as being HARQ fragments. Then SHIC header. So Bob has that document at Interia whereby we will be asking for a new protocol type, a new ether type, and probably a new port number as well for UDP. Unless I'm wrong.
I'll just make a quick report of that. We did get the int area chair and int area AD, interesting that we have the same AD, has agreed to expand beyond that. They accepted my proposal for a protocol number for also an ether type and for a UDP port. UDP port is actually transport area. And the AD over there, David Black, says that it's fairly straightforward in the wording. He doesn't see that, and if we word it properly, that'll just go through, straight through. For the ether type, we are the rablats. There is a new draft coming out for how to interact between IETF and IEEE, and we will be the ones who will figure out whether it's just so that they got that right or it needs more work. So for those of you who have been working with me who want it as an ether type, I don't want it as an ether type, but I'm willing to do the work for that. We're going to be the lab rats for that liaison between IETF and IEEE.
Yes, and we thank Don Eastlake, who has proposed to help us on that and writing this document. and a number of us are participating to the IEEE IETF coordination meeting, and so we'll raise that question at the coordination meeting as well. So we need to talk to Russell Slay. I think he's already aware, but we probably need to just ping him to say, hey, we would like this topic at the next IEEE coordination meeting. Chic header comes as a natural extension to that work. I mean, having a protocol type is good. We need a protocol header to go with it. And we probably need to figure if this is always seen as an upper layer protocol or if there are cases for making it a IPv6 extension header as well. I was kind of the only one on the mailing list trying to say, hey, we might need it as an extension header as well. It might be that some more people get to that thinking that maybe we also need a next header. In which case it's kind of straightforward, it's just that there are two registries. There is the v4 and the v6 registries.
Okay, so for to have a protocol number, the advantage is that it can work on IPv4 and IPv6. If we have an extension header, it will work only on IPv6. But if now we have a port number, so I think we don't have any more a problem of interoperability between these two versions of IP, and we can go on extension for IPv6 and say IPv4 will use UDP on port, which
so
is
we'll
the case
continue
right
on
now.
the mailing list, but there seems to be growing interest in asking that the protocol type is also written as a next header in the IPv6 registry.
Adding chic in an extension header raised a lot of negative comments on the int area mailing list. They were extremely against extension headers for this. They were very much for the protocol number, but you'd have to go back in the archive to see all the points they raised up against extension header. And it'll have to be somebody here who knows an awful lot more than me about this area to try to bring it up again in int area.
Eric Link again. So we can discuss here, right? I have no problem with it, but it's an inter-area draft, but it will be adopted shortly, right? As soon as Bob will add the text for the UDP port and data type, even a couple of links, it will mostly be adopted inter-area. So please comment on this inter-area.
Yeah, we need to figure out if we want it inside before we bother anybody, I guess. But if we could do a quick round on the mailing list just to figure out whether we want it. If we want it, we need to discuss with inter-area. Maybe they say yes, they say no. But we don't even know if we want it before we bother inter-area, right?
I need the use cases for those.
Yeah,
In that
exactly.
draft, I'll need what is the use case for it as an ether type? What is the use case for UDP port? That is, it's not going to fly otherwise.
Okay, so it makes full sense. So the discussion for rechartering for us is whether it's a protocol header or a extension header. We still need to figure. No, the format of our headers, not the value of the protocol type. If UDP has a header with 8 bytes, right? What header do we need for Chic to carry our session? We are defining a new session for LP1. Yes, we need to rethink. But basically, having a protocol type is not enough unless you have 0 byte to carry in your protocol header. But we probably want to carry something like a session ID and stuff. That's what this thing is, right? This is not the interior work. This is a recharter work for us to figure out what our sessions are, how we identify them, what needs to be carried on the wire when the session is not implicit.
Maybe I'm being naive, but the Chic header that I might carry over with Chic being the protocol number will quite depend on the particular use case, whether that header basically doesn't really even exist, just that the rule tells you what it is, or I have to have some sort of compressed content. So I don't think that there's any work to do on that. You already have the basic concept, and it is basically going to be on a usage case basis, just as you already have in Chic. Do you have any here? Depends on what the I mean, the most may be, here is the ID number. And that's it.
Could be,
Just one.
But anyway,
because
that's getting
we
into the
need to
details. That's getting
discuss.
into,
because the people that are remote, if you can announce who is speaking and raise the hand. And there was also Stuart that wanted to
Oh,
interject
sorry.
at some point.
Okay,
So but it's.
let's take Stuart.
Yes, Stuart, are you still interested in speaking to the mic? Because a couple of times, and I don't want to interrupt people that are speaking.
Okay, sorry, Stu. So yeah, I mean, the bottom line is we are identifying the concept of the session right now. We call it the SHIC instance. We are identifying the kind of information that is stored in that session and synchronized, agreed upon between the two parties, the endpoints. And depending on the case, effectively, as Bob is saying, it's more or less implicit. What we would define probably is the list of things that in the worst case must be passed, and how you pass only what you need to pass depending on the use case, boiling down to 0 if you need nothing. And probably the right way of saying that over the wire is SHIC again, right? The rest, the implicit is compressed, but it's the same header, which can be fully compressed. So that's how I figure it. OAM is, we have started the work, there was interest, we saw that there is still interest, but we don't have a charter item for it, so it's kind of an obvious charter item for us. Session setup, that one is a big one. As soon as we are not anymore in a completely controlled LoRa environment or type Sigfox environment where we program both ends manually, etc., then there is a need for a device and an application to agree on a set of rules, make sure that they download the same set of rules, that it is protected against impersonation or any sort of attacks. The rules need to be downloaded, installed, instantiated, meaning if there is your IP in it, the IP is probably not in the rule. You have to instantiate it inside the rule when you install it rule, etc.
Yes, and so I just wanted to add a point here. Throughout the lifetime of the different drafts that became RFCs, we got a lot. Oftentimes, we get reviews from the ISG, and they were asking, okay, what about setting up these rules? How are you going to, like, all this that is put here about the session setup, rule discovery, and all that, and the security of it? We had that questions in the past. Like, people from the ISG were asking, how are you going to do that in a generic setup? And we until now was like, okay, well, we configure it. It's a problem for later. Right now we have solved that, like we have the SHIC, the foundation, and I think it's really the time to, we have the background, the knowledge, the foundation to be actually able to address these specific questions right now, right? I think before that it would have been premature. It would have been trying to solve what. Sorry? Yes, and about the Yang, the optimizations for core conf. So Laurent is going to be talking also about this, but that's really important. Like core conf, it's advancing really well at the core working group, and the way both are going to be working together. That's also an important point. How do we have the most efficient and the most the most way of using core conf over SHIC. So I'm giving the word to Laurent, who was next in the waiting line, and then to Bob, who put for the next one. So Laurent, please.
Yes, security is very important, and here we have different bullets that treat security. Maybe it will be good to have a bullet that says secure the architecture, securing the architecture of SHIC or something, to be very explicit on that.
Well, we don't need to recharter for that. I mean, that's missing in our existing architecture, and Bob mentioned it. So we need to beef up the security section of the architecture, but we don't need to recharter for that, I guess. But yes, I mean, it's an obvious, I mean, nothing would pass without it, certainly.
Yes.
With regard to the negotiation of the SHIC rule functions for the rule between parties, I'll point out that Daniel Miguel already has a draft for running over IKE for how to compress ESP. So that is a good starting point, taking Daniel's draft. And my highly biased opinion is that we only want to do this over a peer-to-peer a secure control channel, not a client server, which pretty much limits us to IKE and HIP as the only two peer-to-peer secure control channels here. I have had comments that maybe TLS kind of can be tricked into this. thus maybe detail less. But it is problematic unless you really know who's, so when we get into this draft, there's going to be the basic question. Is it only a peer-to-peer control channel, or can it be also client server control channel? And that's one that we're going to have to look into and also talk to other security people to answer that question.
So I guess it's very clear that we need a work item on that, because it's not just a few words on the architecture which will make that work, right?
Yes.
Yes. Actually, so that's actually a very, very good point, Bob. And the point here is also, for example, CoreConf, it's working in a client-server way, and typically it's the same thing. So typically you can have, if you have a peer-to-peer relation, you can have both peers to have both the server and the client, so they can have this like peering,
Yes.
like to be like peer-to-peer.
Yeah,
But
TLS, BTLS, you got to play games that both are servers for that.
Yes.
Whereas I can have, that's implicit in their design.
Okay. Well, probably maybe we'll need to define the use cases and see how things are moved, because maybe there will be several solutions to that, right?
Yeah.
So we'll need to really clear out
We
how
need to
things
work in the working group on that.
exactly, and that's a need to they need to work. So
So basically, is there an obvious no-no to any of the elements of this list? Or anything you want to mention? Because if we don't discuss more, basically the chairs will go with this list and try to write some charter. So if you have any comment to help us do that, or if you want us to take off some subjects or whatever before we start drafting, any comment is welcome now and on the mailing list, obviously.
yes. So Laurent.
Yes, for the young model, I think it's not only optimization, but it's extension to the actual young model to apply it to different environment and different management. So it's more about optimization.
So when we word the charter, we'll ask you to.
But we'll try to put all these items in the rechartering proposal, right? Okay. So I don't see anyone expressing negative feelings about any of these points. So this is what we're going to do.
So it's going to be Sergio now.
So yes, thank you. So thank you for the discussion and for leading Pascal. And Sergio is next, and we are almost on time. That's good.
I say next.
Yes, you say next slide. Yes, this
Yes.
thing doesn't work on that.
Oh, yes.
So, well, hello, I'm Sergio Aguilar from UPC. I'm going to present the update on the work that we have been working on the CHIC convergence profile. This is an update from previous interim meeting presentation. We did the individual submission of the draft. We added motivation and use cases. And well, we also added the comparison between CHIC over LoRaWAN and CHIC over Sigfox uplink Archon error mode. In this case, the comparison was already discussed in the interim presentation, but we added to the draft. Next slide, please. Going to the motivation, well, we see that IoT applications normally are tied to the LP1 technology they choose. These LP1 technology constraints influence the design of the IoT application itself. Therefore, when you try to migrate from one LP1 technology to another, you probably need to redesign the complete solution from device code to backend code. So from our point of view, the LP1 should be, as an L2 layer, should be transparent to the application as it is in the IAP domain. Next slide. What we see in current CHIC implementation, we see that we have a single CHIC decompression sublayer, but we see that we have multiple CHIC fragmentation reassembly sublayers. Actually, we have one draft per LP1 technology. But once you analyze the different modes, there are actually really similar fragmentation modes. Therefore, we think that to reduce code complexity and maintenance will be better to have a single convergent CHIC fragmentation and reassembly sublayer. Here we see current architecture that we have. In this case, we have multiple implementation of the check fragmentation sublayer, each per technology that is being used. In this case, well, you can actually send check fragments in different LP1 technologies, but you are not able, well, check packets, I'm sorry, between different LP1 technologies, but you need to have the different codes to be able to manage them. In the case we have a single check fragmentation reassembly sublayer, we will have, we call it check overall profile, that in this case will be the same regardless of the LP1 technology. In this case, you can actually receive check fragments through different networks and actually reassemble the packet at the check reassembly layer. The use cases that we have identified are for multi-radio devices, devices that implement more than one LP1 radio. We also saw multi-network applications. In this case, are applications that are used over several LP or more than one LP1 technology. From there, we also see a use case that this can be a generic fragmentation reassembly profile if you want to test it over a new technology, like to have an out-of-the-box fragmentation reassembly mode. We also see use cases in network redundancy, where you can use another LP1 network as backup. You can send the same fragment or different check fragments through different networks to increase the probability of success, for example. You can also increase the device duty cycle. As the device has more networks to send, you can use another network instead of the one that you are waiting for the duty cycle time. And you can also check coverage of one network, sending messages in one network, receiving the ACK in other networks, so you're able to see if you have coverage of any LP1 network that you have. Here we propose to simplify the access to the rules IDs, to converge all the devices IDs into a single check ID. In this case, we have different IDs, each one from LP1, different device IDs, each from different LP1 technologies. So the idea is to have a single one. Once you have this single ID, you can go to the rules to see what are the rules of that device. We said that this can be done through a table that actually maps the network's devices ID to the check ID, and then we can go and find the rules. This table can be actually extended to have IP addresses, IP ports to identify the packets that are also arriving from the internet. In this case, the comparison that we did about uplink fragmentation, we actually evaluated the check over LoRaWAN draft with, well, a standard with the check over Sigfox option 2. Both in these cases have 2-byte check fragment headers. They have both the same tile size of 10 byte, and they use the no DTAG in this case. And the differences are most related in the window size and the amount of tiles that you can carry in each window. Therefore, we see that since there is a lot of similarities, we can actually converge both profiles with a rule ID of 8 bits, for example. And in this case, we chose to have more windows than more tiles per window, since we can have more opportunities to actually send the ACK to the device. Now with the compound ACK, you can actually send a larger ACK if needed. Therefore, you can have, for example, if before you have a larger window, now you can have the same amount of information in the compound ACK as before. Next. And finally, well, for this draft, we plan to do a new open source project. In this case, we call it Chickduino. The idea is to implement Chick for Arduino. We think that this can help actually the adoption of Chick in a larger extent. With a single code base, in this case, this convergent profile, you can only have to manage as one code. And this can simplify applications that want to migrate between LP1s for multi-network applications. For example, you have an application already, well, you're building the application for an LP1, you're using Chick, then you can migrate the application to another LP1 uh, let's say you by not changing the application code, but by changing the network connector at the end that is between the cheek and the network, but you will have the same code. This allows also fragments to be sent between multiple networks. And well, in this case, the proposition is to build the device code, not exactly the server code. And well, one proposition is that maybe we can use OpenChica server to actually test also interoperability. Yes, Ran, sorry.
Yes, thank you for this initiative. It's very interesting to have different implementation of SHIC for interoperability. But I was wondering more for very constrained devices, if we need really to do compression, decompression on the device and not manipulate directly the SHIC rules, which makes that the code will be lighter. You just have to generate things. For example, co-op can be done in few lines of code because you just send the residues. And so this way you can have something very compact. And that's why, for example, we aim to get the AOM, because of course it's not just sending information, but also to make the device part of the internet. And for example, if you can receive ICMP messages from the internet telling that your server is not available, then the device can react and go sleeping longer just to preserve the battery because nobody is listening to his message. So here we have a very nice scenario where we have very little code on the device, and we have a device that from outside has an IP address and react from internet informations.
Okay. Thanks, Laurent. Next slide.
I want to be on queue as well. Let me put myself on the queue. Sorry. Well, I will just ask a question.
Yes.
Yeah, just to be frank and honest, the two foods that you have may not both survive in the long run. On the other hand, we are chartering for SHIC over foo, and foo could be faster links, like IP, PPP, whatever, MAV links. And so that's where I see the huge value of your work coming in. And so do you consider looking at faster links and making proposal for a generic, for faster foo, better foo or whatever?
Yes, actually, the idea of having the out-of-the-box cheek profile is to enable that kind of interoperability, that you can actually test it over any kind of network. And this way you have like already a profile that is being tested, actually, that we've been working on it since a while, both LoRaWAN and Sigfox. Now that the convergence of both is already been tested in a sense. So yeah, I think that this profile can help actually help over other radio technologies. Yes.
If you explain how to tune some parameters based on whatever differs with this technology, right? Like the speed, if your network is a lot faster, what should you do? If your MTU is a lot bigger, what should you do?
There has to be an adaptation in between the fragmentation layer and the actual network that has been sent. I added a section in the draft that is called downlink considerations. That's where I see that we have to take the actual considerations of each technology. For example, it's different to send, well, it's really similar in LoRaWAN and Sigfox. Let's say you have to send first the message to receive a downlink. But maybe in other technology, you can receive the downlink directly. So this sense, there is specific things of each technology, but I think that these drafts can help use the same fragmentation, but with singularities per technology.
Yeah, because if we are successful with many foods, we can't have as many implementations, right?
Yes.
Bob,
Just some examples of those foo technologies. Consider 802.16 or 802.11 but long range and high capacity usage. So the frames are not so small, but there's just potentially so much traffic that the driver for SHIC is to reduce collisions because of the capacity usage. So that would be the example of the foo use case. for that consideration. In fact, that's exactly what I'm working on.
I would like to add that I started with uplink Econever mode, but we can do the same for NOAC and have a single profile for NOAC, and the same for always well, it's more using downlink, but we can have the 3 different modes also.
Just a short comment. So I like very much your work. Actually, in the beginning of the working group, we were asking ourselves, can we have what we were calling that a minimal profile at the time, I think, where we were saying, can we have like the same minimal rules that can be the same in LoRaWAN and Sigfox, just to at least have like a very basic stuff and maybe have more advanced in each draft. And at that time, I think that we were not, I mean, we didn't know how things will go. So both technologies said, no, we don't want that. Right now you're saying, okay, well, maybe we can find some middle ground, right? So I find that interesting. I found also what Pascal is saying very interesting is to say, okay, how would this work enter in this bigger framework of chic over full, where you can maybe have at some point this minimal profile. I'm calling it the minimal profile if you want to call it the convergence profile, like to say, okay, well, I have this set of rules which are like universal, and I can at least bootstrap my communication over that, right? So I feel that your work gets in that direction, right? The points I'm not sure is how it's going to be working, because there is already the LoRaWAN profile out there. There is going to be the Sigfox profile. And if I understand correctly, they're a little bit different from the things you're proposing here. I mean, it's normal that they're different. So we'll need to figure out. So today you have like a LoRaWAN device, and you will know the chic profile to that device just because it's LoRaWAN, and you know, okay, it's RFC 9011, right? So then we'll need to distinguish maybe, okay, there is the RFC 9011, and there is maybe this convergence profile. So there is this thing of how would that work, and how you apply your work to the chic over full, right? So I think maybe during the rechartering we'll need to look at your draft through that angle, right? Okay, how does it enter in the new charter items, and to see what will be does it fit there? What's the requirement on that convergence profile there? So I don't have an answer to that. I find your work super interesting, and I think that there is a big potential in that aspect, right? But we'll need to look exactly, you know, how it will evolve from there.
Okay,
very,
great.
very interesting.
Yes.
Do you plan also to handle mobility in this scenario, or it's only fixed?
Since we can send fragments through any network, yes, I think that mobility is a total option.
Yes, but more, for example, if you go from a satellite network and you arrive to a new area where you have a LoRa coverage, so it's more in the way you manage the identity in your system.
Yeah, since well, that's we have seen it like the implementation, how the single point where all the, let's say, the posts from all networks, LoRaWAN, let's say Sigfox, satellite, are coming to your server. You have to have a device ID there, that with a single device ID you are able to to know which rules you go, and then you will be able to, let's say, identify that packet at that session, the instance of that packet, or that fragment, I will say. So you will be able to complete the packet, the chic packet. I don't know if I made myself clear. So yeah, the idea actually is that you can send a fragment through any network. So if you are heading to a place that now you have coverage of another network, you can just change and continue sending the same fragments to this other network. That's like the objective also, yeah.
Okay, thank you.
So any more questions, comments?
Just one question on what you said. Probably more interesting or applicable thing would be if you have both technologies and two technologies, or some kind of network coding, so you can send the same fragment on two networks technologies. And, you know, because you're having the same parameters, you don't care which one goes through, right? But I think we need to look at your draft as well from the point of view of this session establishment thing, right? So yes, it's good thing about LoRaWAN, it's good thing about Sigfox. Let's keep that in mind, but also let's look at through the glasses of, okay, I have this session establishment. What do I need to have in this convergence profile?
Perfect. Thank you very much.
Thank you, Sergio.
Yes. So maybe we can give the word to Dominique to have 2 minutes about the hackathon, and then
You submitted the slides, but you are not entitled to push them.
Yeah, right. So I'll just
Let me just. No, it should be very fast. Let me just check.
so we'll have just a minute, a couple of minutes to. Oh, you can share your screen. Oh yeah, okay. I mean, you can.
Okay,
Oh no,
sure.
it is approved.
Anyways, I put them in the.
Okay.
Okay, if you want to share, then there you go. That's the new. Otherwise, they will be available in a second.
Okay.
So the screen share. So yes.
It coming up?
Yes.
Yes. Here you can see our smiling faces from the hackathon on Saturday and Sunday. The names are listed. Martin is not on the picture. She was at the other table right at that time. So what we did is Yvonne and Laurent worked, mostly them worked on cleaning up the OpenShift GitHub repo, merging branches, cleaning up, etc. We had Quentin over there developing a clean slate implementation using MicroPython. If you remember, we originally said we would use MicroPython for embedded devices and then diverge to full Python. So now we have another new implementation in MicroPython. I worked on the documentation. We had Sergio working on the designing the connector between OpenShift and the Sigfox network server. And we did interrupt testing with Martin and the Riot gang. And so we were successful exchanging a few compressed packets in both directions, UDP IPv6 compressed between OpenShift on one side and Riot/libshift on the other side. So not everything works, etc., but it's a good start. And we also exchanged, no, we worked on, but did not complete that, but working on the interrupt between the microShift and the OpenShift implementations. And yeah, what we learned is from the clean slate implementation, Quentin came up with lots of good questions. You know, the way we describe things in the RFC, the design choices we've made in the past, and we could reconsider implementation recommendations, etc. Other ways of doing the same thing with the same toolbox, but organized in a bit different way. And that's what Quentin published his ideas in a draft yesterday night. We're not on the agenda to discuss that today, but that may come up in an interim meeting in the future. Thank you.
Thank you very much, Dominique, and we'd like also to underline that it's really amazing all the work that everyone is doing at the hackathon. So there has been a hackathon on SHIC since I don't know how many years. I think for 5 years on every hackathon, and that's really an amazing thing to have, like the running code. And right now we see all these implementations coming, so it's really an amazing work. So we'd like to really thank all participants in the hackathon. It's really amazing, and thank you for organizing it, and with Laurent for taking care of that. So it's really great.
So we actually consciously let this discussion fly a little bit longer than initially in the agenda, because we thought that the discussion on the convergence was really, really good and constructive. We still have half an hour on the architecture proposal. Doesn't work, Laurent, sorry. And so there we go. It's a bit less than we thought, but Laurent, you have one half hour to.
Okay, so I don't know. I don't think I will have half an hour, but we can have discussion on that because also I will summarize what we say yesterday in a side meeting, if you want. In the side meeting about SHIC and what has been done and all the good questions we got when we published the young data model and especially about security. So we have to merge all these things into the architecture document. So I just remind you here what is the current architecture or what we are where we are going with SHIC. So we have in red here the young data model that are developed right now. And these two young data models are just following what is defined in the two RFCs that define rules and identifier for SHIC. So RFC 8724 and RFC 8824. So IPv6 UDP and CoAP. Can you go back to?
I thought you were giving me a
On this one, and of course we are now planning to augment this model for AOM and CompoNAC. So here it's in red, it's the interoperability part. So it means that different SHIC element can exchange this information. And from that, you have your local representation of the SHIC rules that are optimized for your environment. So here we let people to implement SHIC as they want. We just focus on the interoperability. And this interoperability, if we go to some constraint network, should use core-conf, because here we have a compact way to represent the information we want to exchange. So from that, we had good question about the young model and security. So we had good question during the review of the document. So next slides, please. And one of the question was how to protect element of the rule to avoid that someone can modify some element in the rule, and it was not allowed to do that. So the first reflection we had is that in our views, and maybe we are wrong, we are not full specialists of Young, it's that currently you have some protections that are given in Young to access to a specific field. So here, for example, we have an abstract representation of the rule. So each field will have a specific ID in Young, which will be an URL, or if we are going to core-conf, it will be a number. So all these ID will have the same ID, all these columns, we have the same ID, will share the same ID or the same number. And so what we can do right now in protecting, even in writing in a model, that we can say that a column is write only or read and write, or with the other model, I think it's CACM, we can add to this list some property and say this guy can modify this line and this guy is not allowed. But when we look at what we want to do with SHIC, it's something more precise, because, for example, we can imagine an attack where someone take control of the device and send a management request to the core and say, change this parameter. For example, change my destination address, because this way I will do a DDoS on a specific site. So here, maybe, or maybe not, it depends on the context, we can allow the device to change the destination address. Same thing, the device can change its own address and maybe take the address on another element. So we have to protect that, and to do this protection is not something that is in columns, but we need to have access to one field and say, for example, if we want to change the source address, then it means that we need that the ID1 is source address, and this element is only write only and cannot be modified by the device. So it means that here we have to get an effort to improve, augment the access control that we have already in Young. Maybe we are wrong, but if the case, then you can contact us to say. So that's the first point. So the next point, next slide, please. So here it's resume what I say. So first thing is that but we saw that it's not enough. We have to say that a device can only manipulate its own information and cannot change the information of other devices in a core. So this can be done, for example, must be explicit in what we wrote. It means that we don't have to send IDs on the link, but if a device sends something, it's for its own representation and not for the rest of the model. And then we have the thing I say about the protection of fields, specific fields, and not columns. Yep.
So, just one point here, and I think that was a very interesting, let's say, discovery. The point here is that we want to have basically the same level of security as if the device is running the full IP stack natively. So if someone goes and compromises the device, this is the only thing that gets compromised. So that's the idea, right? And the point is that, so what Laurent is saying is, right now we are talking about having more dynamicity, having the session setup, updating the rules and all that, which is really necessary to get the full power of the shake technology. But the point is that if the device gets compromised, you could imagine that the device can push some rules to the core network, to the application, and these rules can actually match, for example, any packet that's coming from the internet. So it can divert, let's say, all the information that could come to the core network, and it can get all that information by just modifying its own rules, right? And then that's a problem. So that's something that we don't want to allow. And this is something that we'll need to describe, like the types of threats that can arise. So we need to define that, and we need to add this. We need to add the mechanisms to be able to counter this type of attacks, right? So that's what's really important here, and I mean, Laurent went in a lot of details, right? But it was really an important point to say. We need to work on this one.
Right? So yes, that is something that we started discussing at this little meeting. The bottom line is we have isolated, we have understood, clarified that shake operates between two devices, and there is a form of session that happens between those two devices. And during this discussion, what in my view appeared is that you need to identify the session before you start applying the rules, because that's the session which will tell you which rules there are. If you do it in the wrong order and you match based on some rules you have, and then you think, oh, that must be the session, then you might have this sort of attack coming in. If you identify the session, say for a 5-tuple, which basically says this source, this destination packet coming from the internet to the compressor will match this session, then only packets to that destination which match this ACL, this filter, will be passed through the rules, meaning that there is no way through shake to intercept the whole internet, to your point. Okay, so the architecture is missing text on how you identify the session. We are kind of clear for the most piece when the packet arrives in the compressed form, but when the packets arrives from the internet to the compressor, we need to be very specific that first you must isolate the session, say from the 5-tuple and whatever filter. And then once you have isolated the session, then you are within the small world of the target device. That's when you look at these rules.
Okay, yes. So something that is very important, because for the moment, if we don't do that, for example, we can use the flow label as a way to select different devices that will share the same IPv6 address. And we don't want that. We want to keep what is used on the internet. So we don't want to add new feature, but be very close to the IP model. So the other element is, but it's more something that has to be described in the architecture document, is how we install this management between two devices. So either to get all the rules, to modify partially a rule in both directions. So we have different scenarios. For example, a device arrive and ask for its rules, or ask for certain parameters on the rule, or push the rule in the core and set up some parameters in the core. So we have all these things. So how we do that? So it can be, of course, as I say, in the constraint where you have a constraint link, it can be core conf. So it means that we have CBOR and CoAP. So how we run these instances? Do we have to encrypt or to have a security layer all the time? So that's another question. For example, if you use LoRaWAN, maybe it's the cryptographical things offered by LoRaWAN are enough. And then since we are using OSCORE, CoAP, OSCORE, TLS, and all that stuff, of course, since we are compression guy, then we can also define compression rules for this management. And we will have to specify it to have something very compact. Next point, please. So here is the last one. So it's start from a discussion with that Carles push in some interim meetings, and we had a lot of discussion on that. And now I think the model is a little bit more clear, and Sergio add maybe new arrows in this. But in fact, when we were based at the beginning of the group on LP1 architecture, it means that we have a star topology, and it was quite easy to manipulate because we have a central point that was the core of the application and talk with a lot of devices. So what we need to identify was only the devices. But if we move to something more generic, so like a mesh network, then you can have the hosts that talk to other hosts using SHIC. And it means that we have two new things. The thing is that you can have several core, but we have also some dependency, and we have a kind of circle dependency as it is shown on this graphic, because, for example, if you say A is a device and B is a core, then C will have problem because C will be act as a device or a core for the other one. So we cannot say in a mesh network that some elements are core and some elements are devices, but it depends really of the context or what you call the session of instance. So here we represent that in this schema. So you have, of course, these circle dependencies, but we have also some elements that can be both core and device at the same time regarding the rule. So the only constraint we have, and has been published in Evans drafts, is that we need to, if we have this case with the two red arrows, then we cannot share the same rule ID on both sessions. So now, but it's a little bit more clear for us. So we have to implement that in the architecture document and define this notion of session or instance that will either be static, it means that it depends only on information on the rules, or can be dynamic, and then we will have to develop a protocol for our tier tiebreaker to find who's with the device or with the core. With some problems that, for example, if you look at the MAC address, for some time, it's not be something enough because you need to have a server or a client, and the role doesn't depend on the MAC address. So here we have to be very, very careful for doing that, and we have to look at solution in the architecture document.
So the exact language in the architecture document at this point is that SHIC defines a session, so that's the lowercase session. It's just a word, meaning that there is this relationship between two nodes. And we give it a name. We call it the chic instance. That's why you see instance in that slide. So that's the name we give to that session between a device and an application. And we say that there are a number of cases that we list where the session identification is implicit and the parameters are implicit as well. And Laura and Sigfox, no, it's clearly the case. There is no session negotiation. There is never a need to say which session between you and me, there is only one. And which is the rules, there is only one set, etc. Everything is pre-programmed, hard-coded. So there is no negotiation at all and no session identification apart from, the gateway looks at which LoRa device it comes from or something, and that gives him his session. For a Bluetooth low energy where you have a central node and peripheral node, then same thing. I mean, the central node is the server and that's it. So there are a number of cases like this where it's implicit. When we start a transport, like a PPP connection, we also say, hey, the guy who starts the PPP connection is the device. So it's also implicit. There are other things which might not be implicit, that the need for this header, but at least the architecture say there are cases where it's implicit and here is what it's going to be. And then there are cases like the mesh where it cannot be implicit. There are tons of reasons why it could be either one, and for multiple instances, it could be not the same, like represented in red here. In this case, effectively, there is a need of a secure negotiation protocol to make sure both parties agree on what is what. And in the architecture, we don't go further than that. We don't say what that negotiation could be or anything. We leave it to the further work at the after reach out, if we reach out for that.
And I will also add that the work done as 6LO to see how we can put 6LO and SHIC together will be a very valuable input for this document.
Any question before, I guess, we release everybody a little bit earlier? Any AOB discussion, any discussion on this, on Laurent's presentation? Well, that's good for the trains, for those who are waiting for their trains then, and I know a few of them which will scramble. So we thank you for staying to the last minute at this IETF, and we'll organize very soon the next round of interim meeting. We'll start producing text on the rechartering. We'll see what we can write right away on the architecture, not much, but because we need those work items to progress before the architecture can reflect the work group decisions. But yes, let's move on, and you'll see probably in 3 weeks or 4 weeks an interim.
Yes, yes, and we would like to thank the scribes and for everyone that has taken minutes for all the fruitful discussions and for you being here. And hopefully we'll see you in a couple of months again at the next IETF. And in the meantime, we'll have interims. So see you in the interims. And thank you again.
And the meeting is adjourned. Oh, if you wish. And if somebody is rushing to the London Bridge train station, we can always share a taxi.
Oh, merci. I guess.
Oh, you were one of the 11. Okay. Well, Lars said it may work once. Unlikely to work once.